Good morning, our dear listeners, and welcome to our today's class. In today's class, we want to still make efforts to make you understand all the more the links between logarithms of numbers and the indices. And without wasting much of your time, we have some questions that we are going to solve with you today. The detailed provision of the solutions to those problems is, of course, going to be much light in your understanding of similar problems in mathematics and statistics. So we have some questions here to lift up to the board and solve with you. Don't forget to subscribe to our YouTube channel and turn on your notification button so you continue to get our classes. The first question which I have here says, and I write, the very first question says, and I write. That question says, number one, say if log y base what? 3 equals what? X. And log z base what? 2 equals x. Show that 72 raised to power x equals z raised to power 3 y raised to power 2. That is just the question. Question number one. It says if log y base 3 is given as x and log z base 2 is given as what? X equally. We should show that 72 raised to power x is equals z raised to power 3 y raised to power what? 2. That is finding the value of 72 raised to power x in terms of y and z. That's what the question is talking about. So we go about to provide a solution to it. The knowledge of indices and logarithms are very much important in this kind of problems. So let's go there. So permit me to divide this board this way. And we have our solution. Of course, do remember that in logarithm, if you have something like log of y base what, if you have something like log of what? N, log of what? N base a equals what? X in logarithm. It is expressed like this as is equivalence in indices. So you have that this is what? A, which is this base, raised to power this what? X, is given as this what? N. This is true in logarithm as a connection between logarithm and what? And indices. That any day you have this, it can be transformed into this. By saying this a raised to power this x is equal to this n, which is what I have here. So if this is true in logarithm, I can call the idea now to what I have here. So I will now come here and say, therefore, this one is what? Log of y in base 3 is equals what? X. It is going to imply 3 raised to power x is equals what? Y. So I have that 3 raised to power x is equals what? Y. I come over here. So that one becomes that log of z base what? 2 equals what? X. It is going to imply that 2 raised to power x is what? Is z. So I have what? 2 raised to power x equals what? Z. That's what I have. So I'm done with this and with this. So here are we. The next question becomes, what do we do to this 72? So that we can have something that looks like 3 and something that looks like what? 2. It is all on that condition that we can navigate our way out of this particular problem. What we are going to do quickly is to remind ourselves that if you have 72, 72, let us leave the x the way it is. We can have a line like this. We can have a line like this. We ask ourselves, what is the number that can divide the word 72 without remainder apart from 1? That number is what is 2. So we have 2 here. 72 divided by 2 is what? Is 30 what? 6. Can 2 go again? Yes. So we have what? 2. 36 divided by 2 is what? Is 18. So I have what? 18. Can 2 go again? Yes. 2 here. 18 divided by 2 is what? 9. 2 can't go again, but 3 can go. So we have 3 here. 9 divided by 3 is what? 3. So 3 here is what? Is 1. Therefore, our 72 is 2 times 2 times 2, which is 2 raised to power what? 3. So I have what? 2 raised to power what? 3 times. Here is what? 3 times 3, which is 3 raised to power what? 2. How many 2s do I have here? 1, 2, 3 raised to power 3. How many 3s do I have here? 1, 2 raised to power what? 2. But we are dealing with 72 raised to power x. But we have known that 72 is the same thing like this. I will say, therefore, my 72 raised to power x is equals. Here I have what? 2 raised to power 3 multiplied by 3 raised to power what? 2. All raised to power what? X. They are the same thing. And if this and this are the same thing, of course, I can break this into 2. Breaking it into 2 means that this is the same thing as I have 2 raised to power what? 3. Okay? This 3 is also sharing in this x. So I can then come here and say all by what? By x. Multiply by. I come here. This is what? 3 raised to power what? 2. All by what? All by x. Are we there? Now, of course, this 3 that you are seeing here, of course, if you say 3 times x and x times 3, they are the same thing. So the position here doesn't matter. 3 can come outside and x goes outside. Or x comes outside and 3 goes inside. Their answers are going to be the same thing. If their answers are going to be the same thing, it means I can write this in this way. I can say that this is what? 2 raised to power what? X. All raised to power what? 3. Multiply by. I have what? 3 raised to power what? X. All raised to power what? 2. This and this are the same thing. Because 3 times x and x times 3 will give us the same answer. 2 times x and x times 2 will give us the same answer. I will now quickly say but. I will say but. Remember that my 3 raised to power x is y. And my 2 raised to power x is what? Is z. So I will say recall that my 2 raised to power x, 2 raised to power x equals what? Z. And my 3 raised to power x equals what? Y. 3 raised to power what? X equals what? Y. So what I'm going to do is to return back here. Anywhere I see what 2 raised to power x, I will use z. And anywhere I see 3 raised to power what? Y, 3 raised to power x, I will use what? Y. So I will say, therefore, here is my 2 raised to power x. 2 raised to power x is what? Is z. What is the power? 3. Here is multiplied by. Here, 3 raised to power x is here, and 3 raised to power x is y. I have what? Y. What is the power here? What? 2. This equals. I was asked to show that it is the same thing like this. And this multiplied by this will show us that this is z raised to power 3, y raised to power what? 2. Beautiful answer. So that's exactly what we have done here. Very much straightforward. I really want to believe you didn't have a problem. But a situation whereby you had a problem regarding the way and the method and the approach through which we profile the solution to this problem, please raise your concern in the comment section. Surely when we come across to it, we will react to you, provided that you are following us and then you are enjoying the class. Thank you very much. Remember to subscribe to our YouTube channel. Let us clean this one down and then call up also another question and solve with you. This question number 2 says, and I write. Question number 2 says, and I write. That question number 2 says, question number 2, it says, if x, comma y, comma z are three consecutive numbers, or consecutive positive integers, integers, positive integers. Show that log of 1 plus xz equals 2 log y. That is the question. I just have information that x, y, and z are three consecutive positive integers. And you know that consecutive numbers are, if you have a consecutive numbers x and y, and if it may appear that x is greater than what, y is greater than x by 1. That's what they mean by consecutive numbers. So if you write something like 3 consecutive numbers, and you want to begin that number with what? With x. The easiest way you are going to write it is as a word of solution. Let me divide this my line as a word of solution. So I have solution. If you want to talk about 3 consecutive numbers and you want to begin with x, it means that the first number is going to be x, second number is x plus 1, third number is x plus what? 2. So these are 3 consecutive numbers where the first number is what? Is x. I've been told that these x, y, and z are 3 consecutive numbers. And in addition to that, they are positive integers, not negative integers. So if I have what? X, if I have what? Y, if I have what? Z, it appears that this y you are seeing is greater than this x by 1. So I can write that y, therefore, my y is equals x plus 1. And if these x, y, and z are 3 consecutive numbers, it implies that this z is greater than this y by 1. Say therefore, my z equals y plus 1. But you recall that my y on its own is x plus what? 1. So in place of this y, I can remove it and replace x plus 1. I'll say therefore, this my z here is given as, here is my y, I will not write y again, I'll write x plus what? 1, which is x plus 1, then plus this one that is here before. This implies that my z equals, here is my x, 1 plus 1 is what? Is 2. So what I have achieved from this information is that my y is x plus 1 and my z is x plus what? 2. Then I'll now come to what they gave me. What they gave me is log of what? 1 plus. Here is x. Okay? So I'll write x the way it is. I open a bracket. This my z that you are seeing is x plus what? 2. So I'll write what? X plus what? 2. Cover it and cover the what? The bracket. If you open this bracket here now, you end up going to have log of 1 plus. X times x is what? X what? Squared plus. X times 2 is what? Is 2x. You cover it. As a way of solving what is inside the bracket first, looking at this is already a quadratic expression. Seeing x raised to power 2 plus 2x plus 1 is a quadratic expression. So I can quickly come here and call it up and have that. What I have here becomes what? My x raised to power 2 plus what? 2 what? X plus 1. This thing that is here is the same thing with what I wrote here because the signs are the same thing. The highest power of the unknown is what? Is 2. Therefore, it's a quadratic expression. And for us now to factorize a quadratic expression, we are going to look for two numbers we are going to multiply to get us 1. But when we add the two numbers together now, we get what? 2. Those two numbers are what? Are 1 and 1. 1 times 1 is what? Is 1. But 1 plus 1 is what? Is 2. So I can then write this expression as x raised to power 2 plus x plus 1. This and this are not different because x plus x is what? Is 2x. And look at this one and look at this one here. Then we bracket it. So we now open and close and open and close. We look for what is common here. What is common here is what? Is x. So I'll write what? X and open the brackets. So if I have x raised to power 2 and x is already outside, what will be remaining is what? Is x plus. X divided by x is what? 1. Close it. Plus, which is here. The only thing that can go into x and into 1 without remainder is 1. So I have what? 1. Open the bracket. Here is what? X plus 1. Cover the brackets. So the two brackets are now the same thing. So I know I am in line. So I will take this x and take this 1, which is what? X plus 1. And take any of the brackets, which is x plus 1. Of course, x plus 1 into x plus 1 in mathematics can be written as this is x plus 1 all raised to power what? 2. So the whole of this thing that is here has become x plus 1 all raised to power 2. So I will now substitute. So what I have now becomes log. This log. Instead of writing all these things, I'll write what? X plus 1 all raised to power what? 2. And we are told in logarithm that anytime the log of a number is raised to a power, we use that power to multiply the what? The logarithm. So I will now use this 2 to multiply this. So this thing is equals now. Here is that 2 log of x plus 1. But remember that x plus y here is defined as y. X plus y is what? X plus 1 is what? Y. I will say, but x plus 1 equals what? Y. So if I come here, anywhere I say x plus 1, I will replace it with what? With y. So I will say, therefore, this my log of x plus 1 all raised to power 2 is given as 2, which is here, log, open a bracket. This, my x plus y is already y, so I just write what? Y. And that was what, I can even put it in bracket as well. That was what I was asked to show. To show that this is equal to this. Don't you see the value there? That is the value. Because what gave us this is the same question they gave us. Solving it down, we arrive at this. And that is given at this quantity. So we now say, therefore, this is equal to that. Thank you very much for your audience. You see that the idea of indices and logarithm are very, very essential in whatever thing we want to do as it regards problems like this. We continue to make effort to bring things like this before you, so that with time, you find out that you can do it more than we are doing. Thank you very much and stay connected to us.